Have you ever seen that a bridge sways until it collapses just 4 months after its opening? It's the unbelievable story of Tacoma Narrows Bridge, better known as Gallipoli. Hey there, and welcome to your YouTube channel, Civil Engineering with Reza. Today, we will talk about a lesson learned by civil engineers in the topic of bridge design. What is that? Let's see it together. An example of a suspension bridge was the Tacoma Narrows Bridge, which was opened to the public on 1st of July 1940, which was connecting the Tacoma in Washington to Kitsap in Peninsula. In the viewpoint of a bridge, in that time, the bridge was beautiful, slender, and somehow a marvel in its period. But later, people noticed something strange. As I told you, they called a nickname for this bridge, which was Gallipoli. The reason is that during the construction, the workers saw a sway on the deck of this bridge. Then, on 7th of November in 1940, with the wind speed of 42 miles per hour, the building swayed until it collapsed. Some people think that the reason was because of the resonance. Resonance is a phenomena that the natural frequency of the system is similar to the frequency of the applied load, means the wind. But actually, the reason was far from that. What was the main reason? It was the aeroelastic flutter. What is that? In the past, the system under the deck was a truss system. But in this Tacoma Narrows Bridge, they considered two girder system without having any openings. So, because of this condition, when the wind moves from under of this bridge, it had some kind of torsion on the bridge. It means that the winds was absorbed inside the bridge, and by the time the amount of the torsion was increased. So it was the main reason by this condition. Although the Tacoma Narrows Bridge was a painful disaster, but it taught the engineers a painful but valuable lesson. What was that? They need to consider the aerodynamics and aeroelastics in bridge design process. Nowadays, in modern suspension bridge design, mostly the wind tunnel tests, the streamlined decks, and also opening trusses are used to prevent these kinds of fluctuations and failures. In 1950, the bridge was rebuilt with a new one. And after a while, the engineers saw that because of the traffic issue, they need to add another bridge near to this. Finally, in 2007, a twin bridge of Tacoma Narrows Bridge was available for public to use. So, finally, the Tacoma Narrows Bridge was not just a failure. It was a learning class for engineers in bridge design process because it changed the bridge engineering forever. So, nature always wins when it's ignored. But when we respect it, we can make marvels that can last forever. If you enjoyed this tutorial, like and share it with your friends. Hit that subscribe button to be part of our community and learn these kind of failure lessons together. Also, in the comments below, mention that which failure topic you want to cover in our next tutorials. Thanks for watching, best wishes, take care, and goodbye.